Okay, now when we do this, I'm not going to rearrange the terms, I'm just going to expand it first. So I get 12x squared minus 12x plus 3 minus 5 times 16 is negative 80x squared minus 40x minus 5. Now remember, if this question was worth 1, 2, 3, 4, 5 marks, then I could just write the final answer. If the question is worth 6 marks, then you know that they want you to rewrite this question so that all the x's are together. Here's an x, here's an x. All the numbers are together. And we could rewrite this question. But to just save some time, I'm just going to write the final answer. So that should give us negative 68x squared minus 52x minus 2. That should be your final answer. Okay? Now make sure you're writing all these examples down in case I need to see your Edmodo notes for any reason, okay? Okay, so everyone understands that part? Yes? I have a new concept to introduce to you. Remember in grade 10 when we were doing trial and error for factoring, I told you have to get really good at this. And I'm going to teach you the most efficient method, trial and error, because when you get to grade 11, there's going to be a unit guide where you're doing hundreds and hundreds of factoring questions. Welcome to grade 11. This is that unit. So we're going to be doing a topic called rational equations. Rational equations are basically algebraic expressions in the terms of a fraction. So you have a numerator, algebraic expressions in your numerator, and algebraic expressions in your denominator. Restrictions are a concept that goes hand in hand with this. So please write down this definition in your notes. And we're going to talk a little bit about restrictions, but you need this background knowledge first. So remember that whenever you have a certain number as 0 in the denominator, your whole question, your equation becomes undefined. And whenever we're dealing with algebraic expressions with a numerator and a denominator, that's the situation you're trying to avoid. You never want a 0 in your denominator. So the first step when you're simplifying is to factor both the numerator and the denominator. Second step is going to be to cancel out terms that are common to both. So please, this is more important than the last slide. Write these steps down. And finally, we're going to state our restrictions. So I'm going to explain to you what I mean by restrictions. So for each of these rational expressions, I want you to think like, for the first example, I'm going to try to sell you this machine. Okay, that algebraic expression describes a machine. And I'm going to tell you that the machine will always, 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 always work, except when you plug in certain values. So the restrictions are those values that are going to cause the machine to break down. It's not going to work anymore. So Cedric, what would happen if my x was 0? What would my denominator become? 0. What if y was 0, Vicky? What would my denominator become? The entire denominator. 0, because anything times 0 is 0, right? So I know right away, whenever you have a monomial, this is a monomial, one term in the numerator, one term in the denominator. Those are the easiest type of restrictions to state, and we always state restrictions on the original question, not the final answer. I know right away x cannot be equal to 0 and y cannot be equal to 0. If this happens, if either x or y are equal to 0, then my machine is going to break down and I'm going to have a 0 in the denominator. So those are my restrictions. So actually, restrictions should come right after we factor usually. But those are the three components to solving the rational expression. Okay, now what I'm going to do is solve this rational expression, this monomial and the monomial over here. So, first of all, I'm going to combine my numbers, 30 divided by negative 6. And what is my rule when I have terms with common bases but I'm dividing? What am I supposed to do with my exponents? Does anyone know? What is the rule, Roxana? Yes, so I'm going to keep the base the same, and I'm going to subtract my exponent, 4 minus 7. Then here I'm going to keep the base the same and subtract my exponents. Now here's a trick. This is y, but it doesn't have an exponent attached to it. Whenever a letter is by itself, what exponent or what power is usually there, Trian? 1. Good. So this has an imaginary 1 there. So it should be 3 minus 1. Sometimes on the test people wrote 0 whenever there was an exponent there, and that is not correct. Okay, so can someone tell me what is 30 divided by negative 6? Yep. Negative 5. Good. Then I have x to the power of 4 minus 7 is going to give me x to the power of negative 3. And I have y squared. Which term needs to go in the denominator? Right now everything is, we have a whole number here, but what needs to go in the denominator? Yep. X, yes. Yes, x to the power of positive 3 would have to go in the denominator, because right now it's negative 3. So we can rewrite this question as negative 5 y squared over x to the power of positive 3. Negative 5y squared x to the power of positive 3. Now, if I were to state my restrictions on the final answer, I would just say x cannot be equal to 0. And what would I be missing out on my restriction? The y component, right? That is why we never state our restrictions based on the final answer. You always state the restrictions on the original question. Otherwise, you'll be missing out on information, okay? So can you guys please write that down? Always state your restrictions based on the original question, or you'll be missing out on information. So notice, before we state our restrictions, we have to always factor the original question. Otherwise, you can't really state your restrictions unless you factor. Now, why is this question different from the one that we just tackled? Why is it different? What do you think? Okay, so there's a subtraction sign. So instead of having one term, how many terms are in my numerator? 2, and in my denominator as well. So I have a binomial in my numerator and a binomial in my denominator, okay? Mission, what is the greatest common factor between 8 and 28? What number do they have in common? What can I take out of 8 and 28? 4? Is that what you said? Yeah. Okay, so we can take out the number 4. Is there anything else common to both 8AB and 28A? Is there anything else they have in common? Vicky? A, good. So the greatest common factor is 4A. That's how we factor. Now, that's the greatest common factor. Inside the brackets, I'm going to put the leftovers. 8AB divided by 4A is going to give me 2B. And 28A divided by 4A is going to give me the number negative 7. Okay, can someone tell me what the greatest common factor between 42A and 12AB, what do they have in common? 6, and what's the letter that's in common? A, good. Very good, Vicky. And so we're over here, we're left with 7 minus 2B, because 42A divided by 6A is 7. Negative 12AB divided by 6A is going to give you negative 2B. Okay, so I have a very important question for you. Is 2B minus 7 the same as 7 minus 2B? No, it's different, right? Because here the 7 is negative, and over here the 7 is positive. On the numerator, the 2B is positive. And in the denominator, negative 2b is negative, right?